So just to start, how many people have already heard of the term cloud native? Okay, cool. For those of you who heard of this term, do you feel that you have a good idea of what this means? Anybody have a cool? So this is fairly common, and I think actually kind of similar to what we saw with DevOps. And this is what I see talking to colleagues and peers and clients, is that there's not really a great kind of definition or a clear understanding of what this means. And that kind of was my inspiration in trying to put this talk together. So short introduction, as Aaron said, my name is Ian Crosby. I work for a company called Container Solutions. If you haven't heard of us, I don't feel bad. We're primarily based in Europe. The largest office is in Amsterdam, but as of September, we've opened an office here in Montreal, so that's why I'm here. So we're excited about that. And we focus a lot in this cloud native space. This is really, our main focus. We're kind of technology people, and this is where we play. We're professional services, and what we do primarily is cloud migrations. So it's helping organizations who want to move towards the cloud, who want to adopt cloud native practices. And so this has fed into a lot of this presentation, and where I've had these discussions around what cloud native is and how do you actually get there. So there's three main points or three questions that I want to try and answer today. The first obvious one is, what is cloud native? I'd like to get to a point where we have kind of a shared definition, or at least a shared understanding of what this term means. Once we have that, I want to try to explain why this matters. Why should you care as a developer or as an operations person, as a manager? Why is this important? And then once we've aligned on a definition and we all agree that cloud native is amazing and not just hype, I'd like to share some tips on how you can start to get there, how you can help your organization start to get there. And again, this is based on working with a lot of different companies who have kind of gone down this cloud native road, and some successes and some failures. So I just wanted to start with this kind of famous quote that we have about the difficult things in computer science, right? Naming things is hard, and we're not traditionally in the tech world very good at it, which is why we have terms like the cloud to begin with. But it's also really important to name things, right? And this is where we want to avoid things like just getting into hype or things being dismissed as a fad. If we don't understand what the term means, or if we have conflicting definitions, this is the risk that we run. Or even worse, sometimes the terms can get kind of co-opted by vendors, and they kind of take over a term for their own specific means, and then we lose the original intention. So this is why I think it's really important that if there is a term which we feel is relevant, and this one I think is, then it's good that we can have a common vocabulary to explain it, and we're talking about the same things. So, let's start with that. What is cloud native? Let's see if we can try to answer that. I'm obviously not the first person to try and define it, so a good place to start is to start Googling and look for some definitions that are out there. And one that you'll often see, or some kind of variation of this, is going to look like this. This specifically comes from Pivotal. So those are the folks that brought us Cloud Foundry. So they're very familiar in this space. They've been in it for a long time. And I want to pick this definition apart just a little bit. So, I can't argue that this is incorrect at all, but I think it's a little bit vague, right? I mean, if you're looking to get into this space, or you want to, start bringing your company to become more cloud native, this doesn't really give you a lot to go on. However, one thing that is very useful is the end. It talks about exploiting the advantages of the cloud computing model. And I think this is something that is at the heart of cloud native, is that we've made these large technological advances. We have these new tools, these new systems available to us. And the idea around cloud native, or one of the main ideas, is to build our systems to leverage these two tools. So we really want to leverage the cloud. There's just one problem, that there is no cloud, as we all know. This is another example of bad naming. I have a personal pet peeve with the term the cloud. But it's just other people's computers, right? So how can we leverage this? Well, this isn't entirely accurate because it's not just someone else's computer. It's millions of computers. And this is the idea of the cloud, right? We have essentially an infinite amount of compute resources. So if you think about the system that you currently work on, if you could get to re-architecture that and you had unlimited compute resources at your disposal, what changes would you make? How would you architect it differently? And this kind of, again, gets to the heart of what cloud native is about. We have these technology, we have these resources available. How can we architect our systems in a different way? But I'll get to the challenges in a little bit because it's not all just bright side, right? Yes, we have this infinite amount of resources, but as we saw, these are other people's computers. So for one, we're going to have to pay for them. So we have to factor that into how we create our systems. And also, again, these are other people's computers. We can't necessarily rely on them. Things are going to fail. There's going to be things that break. Servers are going to go down. Networks are going to fail. So we also have to think about this when we're designing our systems. We want to build systems that ultimately are resilient and ideally become stronger with the chaos that's out there. So if we look for some other definitions that are out there, this comes from the Cloud Native Computing Foundation. So they're definitely a bit of a standard in terms of cloud native. And this comes from their charter. And this kind of gets into what the first definition missed a little bit. So where the first definition from Pivotal was a little bit vague on what cloud native architecture looks like or what are the pieces involved, here we get a little bit more specific. So there's 3 specific things that I want to pull out of here, where it talks about running each piece, your application in microservices. So a microservice architecture. It talks about running each piece in a container, and then finally having dynamic orchestration. So I'd like to pull out each one of these and talk about them just a little bit. So the first one is microservices. And Nicole talked about this a little bit in her presentation earlier. But the basic idea is that we have a large, what we now call a monolithic application, and we just want to break it down into individual pieces. And this aligns much better with the idea of cloud native, or running our applications in the cloud. A couple of reasons are because of scaling. If you have just one big piece for your application and you want to scale that, well, you have to duplicate the entire piece. But if we have these individual pieces of our application broken out into microservices, then we can only scale the piece that's necessary. Additionally, what if we have all these computers, all these resources that we want to run our applications on? Well, how do you split up a giant application to run it on multiple computers? You can't really do that. But again, with microservices, we can leverage all these different pieces. We can run our different services across different VMs, across different hardware. So microservices is definitely a very strong factor in cloud native applications. So the second piece was about containers. And specifically, we want all of our pieces, all of our services to be containerized. Now, I want to make a strong distinction here between any specific vendor or specific technology, because where maybe 90% of the time these days, this means running it in a Docker container. We don't want to tie that to the definition of cloud native. What we want really are the advantages of containerization. We want to ensure that we have isolation between our different services, and we want a common format. So this means that whether I'm running a JavaScript application or I have a backend Python service or even a database, if I'm packaging them all in a common format, that means I can use the same tooling for building, for managing, and for deploying my services. So this is something that, again, Docker containers is one example, but even recently we've seen a lot more new technology, which is a bit of a hybrid between VMs and containers. So there's things like gvisor, which came out of Google, Kata containers. AWS announced Firecracker last year. But the benefits they provide are all the same. We need isolation, and we need this common format for our applications. So the third piece was around dynamic orchestration. And if we take a monolith application, if we break it out into all of these different services, and we containerize all these pieces, how are we supposed to manage these things? Clearly, you can't do this manually. You can't be deploying all of your different pieces, manually to different servers. You can't have any manual interaction in terms of monitoring their health or scaling them. So what we need is some kind of platform which gives us this dynamic orchestration, which takes care of things like monitoring their health, like scaling them, like scheduling them on different machines. Again, the most common tool that we're going to see here is Kubernetes, but we don't want to tie any specific technology to this definition. There are other tools that do this, such as Mesos, such as Docker Swarm, but it's the concepts they provide that are more important. Really, I think the idea here is that if I'm responsible for some production system and I have a server that goes down at 2 in the morning, what I expect of this dynamic orchestration is that it's going to recognize the failure, it's going to be aware of any applications that we're running on this server, it's going to find a healthy server, and it's going to redeploy all of my services to healthy places. And ideally, this is going to have no impact to my customers and not wake me up. So this is really what we want from dynamic orchestration. So these are kind of the core pieces that come out of the CNCF definition. Now, another place that we can look to try and see, what is a good example of cloud native is to look at companies that are doing this. And again, Nicole mentioned Netflix earlier, and they're often put up as kind of the poster child of DevOps and of cloud native, because essentially they were doing this, before cloud native was even a term. So a lot of the processes, a lot of the tools that we currently use kind of came out of Netflix. So it's very relevant to look at, what they did do and what are some of the practices that they have going on. Well, none of us are going to be running at Netflix's scale. It doesn't mean we can't take advantage of the same practices. So, a few examples, beyond the fact that, they went very in onto the microservices architecture, are they really leveraged public cloud? So specifically, infrastructure as a service from AWS. They went all in very early on because they had, tremendous scale, but also, their traffic varied a lot. So in order to not have a bunch of servers that were just kind of be sitting idly for half the day, they decided to leverage this new idea of infrastructure as a service, and then, shift this off to another company's responsibility. And from the infrastructure as a service, there's other things that we can leverage, such as SaaS, hosted databases, hosted monitoring. Essentially anything that's not within your core realm, you can leverage this as a service from some cloud provider or some vendor. Another thing which Netflix made very famous, actually kind of pioneered, which again Nicole commented on, is the idea of resilience testing, or what they now call chaos engineering. And as she rightfully said, this doesn't mean you have to do this in production. But the basic idea is that we want to go out and intentionally cause harm to our applications to learn what happens and to be prepared for failure when these things do happen in production. I think a big shift in mindset in going towards cloud native is that we're no longer in control of everything. We can no longer try and ensure that nothing breaks, because things are going to break. That's a guarantee. So instead, we want to build our systems in such a way that, again, they can handle these failures and they're resilient. So, introducing chaos engineering or resilience testing is a really great way to ensure that we understand our systems and we're prepared for when things actually fail. So, are we any closer actually to a definition here? Well, we've seen kind of a few different good examples, and I think there are some common trends. So I've tried to pull this together in what we'll call the basic cloud native principles. So the first one is, microservices oriented architecture. And again, we saw that, a monolithic kind of style architecture really doesn't fit well with the cloud. We need individual pieces that can be scaled independently, deployed independently, and composed into larger pieces as well. I'll say microservices oriented because there are some kind of gray areas. And also this is kind of a shift, right? It's not just a one or the other. We tend towards this idea of microservices by breaking up our large applications into smaller pieces. We also don't want to exclude things like serverless, for example. Serverless isn't really considered microservices, but it's definitely something that fits in with a cloud native pattern. So the second piece is containerization. And again, I just want to repeat, this is not specifically that you have to run everything in Docker, but this is about having that level of isolation around all of your services, around all of your databases, all the pieces that you're responsible for running. And to have this common format. So that again, we can use the same tooling to manage all of our applications, and we can have the freedom to choose the right tooling that's out there. And then once we have these pieces, we saw that we need dynamic orchestration. We need these platforms which are going to be responsible for ensuring that our applications are up and running, ensuring that they scale as needed, and being able to monitor them. And we really want to leverage these technologies that are there from the cloud. So infrastructure as a service, platforms as a service. For example, if I decide that I want to move to Kubernetes, and we have a choice of managing and running our own clusters or using a managed Kubernetes service from one of the big cloud providers or even some third-party vendor. For me, this is kind of a no-brainer. Managing these kind of clusters are really hard work. So if I can get somebody else to do this for me, that's not in my core business. So these are the technologies that we really want to use. And then finally, automate everything. In kind of a cloud native system, there's no room for manual action. There are too many pieces involved. Things are changing too quickly. As soon as you have manual actions that are necessary in your build pipelines, if you have manual testing that you need to do, you're just going to break down and grind to a halt. So we really need to get to this phase where we just automate away everything. So now I hope we have kind of a common understanding or a common vocabulary we can use to talk about cloud native. Then the second question was, why should you care? So I want to get into a little bit of the benefits of cloud native. So I feel this is a better way to build software, to build bigger systems. So let's try and look at why that is. So I want to start with this common idea that we often have in our heads of agility versus stability. And this is a conversation which I've had many times with organizations who maybe a bit more on the enterprise side, and they want to adopt more agile practices. They really want to do continuous deployments. They want to be able to release features much faster and react to the market. But they say, we're not startups. We have strong SLAs. We can't afford to have issues. We can't afford to go down. Our clients won't allow that. Well, the thing is that, why is this necessarily something that we have in our head, that we have to be either agile or be stable? Well, I think, we're used to seeing a lot of these things, coming out of the startup world, right? Of we have to, move fast and break things. And this kind of implies that if you're moving fast, you're going to break things. So immediately, anybody in, be it a banking sector or anything else, in an enterprise world, kind of sees this thing and you get scared. You're like, well, I don't want to break things. Well, this one actually comes to us from this guy, who I don't think any of us really want to be taking advice from him anyway these days. But the good news is that, in fact, we don't have to. Is anybody familiar with the ADORA, DEVOPS Research Association? So they do some really good research, and every year they come out with a report on the use and adoption of DevOps and cloud native practices. And they cover a really large number of organizations, and they ask them about different practices that they have in place, how often they release, all these kinds of things. It's really interesting. It's all online. You can check it out. This book is kind of based on the DORA practices or the DORA research itself. It's also pretty interesting. And this is from their 2018 State of DevOps report. So it came out a couple months ago. And essentially, they put companies into different categories from kind of the highest performers down to low performers based on certain measures. And these statistics are looking at comparing the highest performers to the lowest performers. So if we look at these two things, we see that the high performers are making 46 more times deployments. So they're way more agile. They're making way more changes to production than the lower performers. And the time it takes from a commit to actually get deployed is 2,500 times faster. Right? So these organizations which have adopted the cloud native and DevOps practices are just going, they're much more agile. They're releasing features a lot faster. They're moving a lot quicker. But what's really interesting is if we look at the other half of this slide, these same companies also have a 7 times lower change fail rate. So that means when they do make a release to production, they're 7 times less likely to have an issue. And on top of that, again, over 2,500 times faster to recover from incidents when they occur. So when something breaks in production, they're 2,500 times faster to fix that than the other guys. So in fact, what this teaches us is that we have this false misconception between agility and stability is wrong. It's actually, we get both, and they kind of feed off each other. And if you think about it, it makes more sense, right? If we deploy more often, then these processes get more smooth, we're better at it, we understand how it works, and we build a more stable platform. And of course, when we have issues, because our deployment process is so smooth, then it's much quicker to fix them. So another strong benefit of kind of cloud native practices and cloud native systems has to do with how we deal with risk. So risk in generally is a very bad thing when we think of in terms of software. And if we go back to kind of the waterfall days, we do these kind of really long release processes where we would build up this 6-month release, and we go through this coding and testing. And then we get to the very end and we see that, we have a problem. And you have to go all the way back, right? And this was because we carried this risk all the way onto the very end. We didn't realize that there was going to be problems. And then from there, we moved into the agile world, and things got a whole lot better. We came up with this idea of these more frequent iterations. So maybe we still have a release further down the road, but we'll do 2-week sprints. And at the end of these 2 weeks, we'll go through all the testing and releasing, and then we'll find problems earlier so that we don't get all the way to the end. So this was a big improvement. But in more of a cloud native world, we don't really have this concept of releasing anymore. We get to this idea of always on software. And so when we're starting a project, we jump into this idea of building out an MVP, whether it's a new product or just a new feature. And then immediately you identify where the risk is. You build this out in code, and immediately you bring that risk down. And then you just get into a phase where you're kind of constantly making incremental changes. And because these changes are so small, the risk goes down more and more. So one more point on the benefits. Is anybody familiar with Conway's law? So this is a bit of an old one, but still very relevant. And so what he says here is organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. And essentially what he's saying is that, as an organization, the systems we build or the software that we build reflects our internal communication systems or communication structures. And this was back in the 60s, even before we were building large software systems, but it still holds very relevant today. We can see some famous examples of this. But what's really interesting is that we have this concept of what's called the inverse Conway. And this is the idea that we can actually affect the communication structures of our systems at the same time as we're affecting our architecture. So if we introduce an architecture and want to reflect that within our communication systems, these things are very strongly tied. So the idea is, if we move to a more of a cloud native system, then our communication structures have to shift as well. So just as we saw that, with DevOps, it's a big cultural shift. We have to look at how our organization, how our teams are structured. The same is true with cloud native. And I think that this results in a much better environment for us as developers and for ops people as well, because we end up with this idea of, autonomous teams where, I don't have to rely on some release team to tell me when I can make a change to production. Or I don't have to wait for, a network security team to open up a certain port for me in a firewall. Because these processes, are just going to grind the whole cloud native thing to a halt. So we have to get the efficiency of getting these out of the way. And then we end up with, again, autonomous teams, which are able to make changes on their own. And we're not just writing code anymore and shipping it over to other teams to deploy or to manage, but we own the team throughout. We own the code throughout. So the code that I write, I'm responsible for testing, I'm responsible for deploying, and responsible for it in production. And this, gives us a sense of ownership as well as developers. So if I haven't convinced everybody already that cloud native is a wonderful thing, then hopefully I can scare you and say that this is the way that things are heading. For large scale systems, cloud native is the way that things are going. And especially we've seen this within the past year, the adoption has been just huge. So I did a few talks last year talking about this idea of Kubernetes specifically and its attempt to cross the chasm. So if anybody's not familiar with this idea of crossing the chasm, it comes kind of from the marketing world. And essentially, when a new technology comes in, it gets, there's early adopters and kind of the innovators who take on. And then to get to the actual mainstream can be quite difficult. And there's a lot of kind of famous technologies which have not made it. But early last year, Kubernetes was kind of in this middle ground where it was starting to get into the mainstream market, but it was still in this chasm crossing phase. Well, what we saw, at least up until the end of last year, is that it has essentially crossed the chasm. It has reached the mainstream market, and Kubernetes is kind of the microcosm of cloud native itself. 2018 was kind of a huge year for these technologies between the adoption rate of Kubernetes and other cloud native tools, the large acquisitions that we saw, Heptio getting acquired by VMware, IBM paying $34 billion for Red Hat, which it specifically said was about their hybrid cloud solution. So that's a pretty big investment. And there's a multitude of statistics of surveys out there where large companies have identified that the cloud is their future. The cloud native is where they're heading. So hopefully now I've convinced or at least scared everybody that cloud native is something you should be aware of, you should be familiar with. So now I'd like to share kind of some tips on how can you get started, how can you further yourself or further your team towards cloud native. So the first thing is just start learning. Right, there's a lot of hype around this specific space. So rather than just doing what other people kind of suggest, go out there and learn a little bit. There are tons of resources available online, from tutorials to millions of blogs to online trainings and workshops. Cloud native is built on open source, so you can go out and read the source code of all these tools. So that's the wonderful thing about it. And if you educate yourself a little bit around these, then you can start to see whether this is right for you, whether this is right for your organization, and then you can kind of start things internally. So running hackathons, doing trainings within your organization. The next thing is about starting small. Really migrating or transforming an organization to cloud native is a huge project. It's a huge endeavor. And it's not something that should just be done in one fell swoop. So, start with a specific project. If there's something new that's being built, or maybe something that can be done easily, try doing this out with some of the new technologies and seeing how it works, seeing how it fits into your organization, fits into your team. The idea is that you want to get into this cycle of, actually running experiments, analyzing the data, and then seeing what you learn from there. And this kind of cycle of building, measuring, and learning is kind of at the core of cloud native in general, right? We always want to kind of have this bias for action. Of course, there's some challenges as well. So I just want to highlight some of the difficulties that people run into when they start moving towards this world. One of the most common things is that, somebody gets inspired and says, they see the technology, and you take an existing one of your applications, you run it in Docker, and you see, this is actually pretty easy. The tooling is very developer friendly. So from there, maybe you take a couple applications, use Docker Compose, you're able to spin them up, you're able to scale them. Seems pretty easy, seems pretty straightforward. At this point, you're like, okay, we're ready to go full cloud native. You get buy-in from the management and for this full 2-year project to go ahead. And that's where the complexity really grows exponentially. Somewhere along there, there's kind of a panic moment, and then you're like, okay, we need to call for help. So the tools and the technologies that are out there make a lot of things much simpler, which is why when you first get started with it, it gets a little bit addictive, and you can see that this makes a lot of things easier. But in fact, the complexity really gets shifted to some other areas. So, don't be fooled when things just start simple, or seem easy at the beginning. There is complexity hidden in there. Not sure if you can see it, but in the background, this is actually a dependency graph from, I think, AWS, Amazon, just showing, all the dependencies between their different services. So this is the kind of, even though we're not going to be running at Amazon scale, this is the kind of complexity that can exist. Of course, if you're taking one application and splitting it into microservices, then all of your in-process calls are now going calls across the network. And if you're now splitting these services up until a bunch of different VMs running in the cloud, these are calls that are going between different VMs and between different regions. So this is a whole new level of complexity that we essentially didn't really need to deal with before. So speaking of complexity, so this slide is kind of a good and a bad thing. This is what's called the CNCF landscape from the Cloud Native Computing Foundation that I mentioned to before. This again is up online on their website, and essentially this is where they're keeping track of all of the tools, all of the vendors, all the platforms in the cloud native space. So, and I probably pulled this off like 2 weeks ago, and it's probably already out of date. The great thing is that these things are probably 90%, if not more, all open source free tools. So there's a lot of resources out there available to solve your challenges, to solve your problems, to help you get started. But of course, the problem is this is really overwhelming. How do you know which tools to use? How do you know where to start? How do you know which tools are even going to exist in a year? This can be very challenging. So again, don't just go and read some blog post and see what somebody else said and say, oh, we should use these tools. Do your own research and find out what tools actually fit your situation. And again, with the idea of starting small, try one tool at a time, seeing what problems that solves for you, implement that, and then add more as needed. Another problem that, kind of an issue that we run into often is this conflation between technology and cloud native in general. So if a company says that, hey, we're running Kubernetes, so that this means we're cloud native. There's a lot more to it than just the technology. The technology definitely enables it. It helps it a lot. But there's a lot more to it than that. So, similar to, again, Nicole was talking about this idea of DevOps being a cultural shift. The same is true for cloud native. It's about more than just bringing in automation or bringing in the right tools. So this is a tool that we use to kind of measure the maturity of different organizations in terms of cloud native. As you can see, there's a lot of different features here that you need to measure, including culture, including the processes you have, including your team structures. And essentially, if you're not maturing all of these things at the same rate, then you're going to have issues. I mean, there's no point in me moving to a microservices architecture if I still run all my applications in a couple servers in my server closet. All of these things are really strongly intertwined. So just to kind of summarize some of the key points here, again, cloud native is really about leveraging the cloud. So it's leveraging the technology that's out there, leveraging the open source tools, leveraging, again, these infrastructure as a service, software as a service, all these new resources that are available to us. And it can help us build more reliable systems and build them quicker. So again, by being more agile, we can actually be more stable. And cloud native practices can let us do that. It does, of course, come with a whole new set of challenges. It solves a lot of problems for us. It opens a lot of doors, but it comes with its own challenges that we're running into. And then finally, it is about a lot more than the technology. So just bringing in Docker and bringing in Kubernetes is not going to move your team to be cloud native. This again is also a cultural change where you have to adjust your processes, adjust your team structures to reflect your architecture. And just kind of a final note is that cloud native also is not an end state. In fact, the idea is that there is no end state, right? These systems we want to build, we want an evolutionary architecture. So the idea is that can be responsive to change, because change is going to come constantly. So if we build our systems that are able to respond to this, can we make changes quickly? That's what we're actually aiming for. We're not trying to set some architecture that's going to be an end state at the end of the day. So that's all I have. Thank you.